Find the square roots of 16 plus 30i. So the square root of 16 plus 30i is some complex number a plus bi, where a and b are real numbers. Knowing that, we can square both sides. To get that 16 plus 30i must be equal to a plus bi all squared, or 16 plus 30i is equal to a squared minus b squared plus 2abi. Equating the real parts, a squared minus b squared is 16. Equating the imaginary parts, 2ab is equal to 30, which means that b is equal to 15 over a. So a squared minus 15 over a all squared is equal to 16, which gives us a to the 4 minus 16a squared minus 225 is equal to 0. First of all, expanding this and then rearranging. This is a disguised quadratic and factorizes to 25 and 9. We're going to need minus 25 and positive 9, which means a squared is equal to 25, or a squared is equal to negative 9. This one is not possible, as a is in real numbers. So a is equal to plus or minus 25. Substituting in here, b is equal to 15, sorry, not 25 though, is it? Plus or minus 5. b is equal to 15 divided by 5, so it'd be 3, or 15 divided by negative 5 is minus, so plus or minus 3. So the square roots of 16 plus 30i is equal to 5 plus 3i, or minus 5 minus 3i. Moving on to part 2, use your equation to solve the following equation. So in part 2, we have an equation, a quadratic equation, z squared minus 2z minus 3 plus 7.5i. It's a quadratic equation where one of our terms is complex and our solutions are also going to be complex here, but we don't know that just yet. How do we solve a quadratic equation? Well, we clearly can't factorize this, so let's use the quadratic formula. The quadratic formula, z is equal to minus b, so minus negative 2 is 2, plus or minus the square root of b squared, which is going to be 2 squared, which is 4, minus 4 times a, which is 1, times c, which is minus 3 plus 7.5i. Let's extend that square root a little bit so it goes all the way. And all of that is over 2 lots of a, which is just 2 in this case. Scroll down to give me a bit more space now. Simplifying this, we have 2 plus or minus the square root of 4. This minus and this minus are going to make a positive, so plus 4 lots of 3 plus 7.5i all over 2. So that's 2 plus or minus the square root of 4 plus 4 times 3 is 4 times plus 12, which is 16. And then 4 times 7.5 is going to be 30 plus 30i. But now we see why we did the first part, because this is what we worked out here. So now we can replace that with the positive solution, which in this case is going to be 5 plus 3i all over 2. And we could leave it like that, but we can simplify this down a little bit more. So 2 possible answers, 2 plus 5 would be 7, and then plus 3i all over 2 when this is positive. Or when this is negative, we get 2 minus 5, so minus 3, and then minus 3i all over 2. So we get 2 solutions to this quadratic equation, but in this form. Now, why did I choose the 5 plus 3i and not the minus 5 minus 3i? Well, actually, it doesn't matter. If we chosen the minus 5 minus 3i, we would have got these the other way round, because the plus minus would have cancelled with those negatives in the other way. We would have got the same answers, but we would have got, this one would have come from the plus part and this one would have come with the minus part. So it doesn't actually matter which of those 2 solutions we had chosen. So this is how we can use these ideas to help evaluate and solve quadratic equations involving complex numbers.